Okay, so we've got one more example here, and this one's a little bit tricky. So if we look at this limit, we've got the limit as x approaches 0 of the quantity 1 plus 2x raised to the negative 3 over x. Now, if you take the limit of the base, right, so we've got the limit as x approaches 0, 1 plus 2x, that's going to be 1. And you take the limit of the exponent, the limit as x goes to 0, negative 3 to the x. Actually, I guess we should be doing this from the left. That goes to negative infinity. This is an indeterminate form. So we're going to try to use L'Hopital's rule again. But to use that theorem, we have to get it into this form, 0 over 0 or infinity over infinity. So we're going to have to do a bit of fancy footwork to do that. And so what we're going to do is we're going to say, let y equal that expression, 1 plus 2x raised to the negative 3 over x. And now the reason we want to do that is because we're going to take the natural log of both sides. So we're going to say the natural log of y is equal to the natural log of this expression, 1 plus 2x, that whole quantity, raised to the negative 3 over x. And the reason we want to do that is we want to use the log rules to get our hands on this negative 3 over x. So we get the natural log of y equals negative 3 over x times the natural log of the quantity 1 plus 2x. Okay. So now back to the limit part of it. So now instead of taking the limit of that expression, we're going to take the limit of these expressions. So we're going to take the limit as x goes to 0 from the left of the natural log of y equals the limit as x approaches 0 from the left of, and I'm going to rewrite this a little bit, negative 3 natural log of 1 plus 2x all over x. Okay, so let's see what happens. I'm pretty much going to ignore what's on the left side. We've just got the limit as x approaches 0 from the left of the natural log of y. I'm going to leave it like that. On the right side, what happens with our limit? Maybe I should do it up here. We've got the limit as x approaches 0 from the left of the numerator here is going to be negative 3 times the natural log of 1 plus 2x. So that's 1 plus 0, or the natural log of 1, all over 0. But the natural log of 1 is 0, so you end up with 0 over 0, right? So we've got it in that 0 over 0 indeterminate form. And now we're going to apply L'Hopital's. Right? So that means we're going to take the derivative of the numerator. So we're going to take the limit as x goes to 0 from the left. So for the numerator, that's going to be negative 3, right, times, now the derivative of the natural log of 1 plus 2x is 1 over 1 plus 2x times the derivative of 2x, which is just 2, all over x. I'm sorry, the derivative of x, which is 1. All right, so things are actually looking pretty good now. Let's see if I can remember what we get here. So this is going to be the limit as x approaches 0 from the left of negative 6 over 1 plus 2x. Right, so we've got the limit as x approaches 0 from the left of the natural log of y equals the limit as x approaches 0 from the left of negative 6 over 1 plus 2x. Okay, so let's see if I can remember that for our next slide. All right, so we've got equals the limit as x approaches 0 from the left of negative 6 over 1 plus 2x, and that's equal to the limit as x approaches 0 from the left of y. Now this is a limit we can find pretty easily. So if we take the limit on the right side, we're going to get basically negative 6, right? We get negative 6 over 1 plus 0. So we get the limit as x approaches 0 from the left of y is equal to negative 6. So basically we're saying that the limit, whoops, I forgot the natural log. This should be the natural log here. Sorry about that. The limit of the natural log of our original expression is negative 6. But we didn't really want to find the limit of the natural log. So what we want to do is basically sort of undo that natural log we did both sides. And this goes back to our log rules again. We can raise both of these sides to raise e to both of these powers here, right? So we can say e to the ln is equal to e to the negative 6. So this is true. This e to the ln though, if you remember your exponent and log rules, that's actually equal to e to the ln is just equal to y. So the natural log of y, x approaches 0 from the left of y, is equal to e to the negative 6. But this y, if you remember, that was sort of artificial. We placed it in there. That was our original expression, right? So this 1 plus 2x raised to the negative 3 over x, right? The limit of that then is equal to e to the negative 6. So like I said, this one's a little complicated. You had to do a little bit of fancy footwork to get our hands, right, using the logarithm rules to get our hands on that exponent, and then find the limit of the natural log of that expression, and then finally raise both sides, raise e to both those sides of the equation. You end up with the limit of that original expression. So the limit as x approaches 0 from the left of the quantity 1 plus 2x raised to the negative 3x is equal to e to the negative 6. All right, so you should try some of these problems now. Right, I listed a few down there. You should do a few more of those. Get started with your homework. Work together. You can replay these videos, pause them. Just make sure you understand what's going on. This L'Hopital's rule is a really useful theorem for finding the limits for some of these expressions. We wouldn't have been able to find the limit for most of these expressions we talked about without L'Hopital's.